what not to normally wear. If you want to know that, just look at Brendon or myself. On that note, I'm Kenton. This is Brendon. We're both developers at The Nerdery, which is an interactive software company here in the Minneapolis area. We both do Android. Brendon also does iOS. He claims that makes him better than me. It probably does. We're both largely new to wearables and apps that run on them, but it was something that we were both pretty fascinated with. So we kind of set out to try and learn more about them just through the process of actually trying to create an app. So we wanted something that would be straightforward to do and that we could also actually see ourselves using. So this presentation is basically going to be our story of that process. Hopefully it's interesting. So here's kind of a basic outline of what we want to go over. We want to talk about what exactly is possible on wearables and wearable apps. When should you bother making a wearable app or bother making more extensible support to a wearable? What kind of goes into designing a wearable-integrated app? And then finally kind of what it looks like to make one on both Android Wear and WatchKit. So there's going to be a section for both.
How's my mic? Okay. All right, so starting out, I want to talk a little bit about what wearables do and what the apps on them, the sort of things that the apps on a wearable device might be good for. First one is, of course, notifications, just getting them up off of your phone and onto your wrist for an Android Wear device, so you can see them without having to get your phone out. The next one is along the same lines as notifications. It's just contextual information that might be relevant to wherever you are or things that are currently happening. This, I like to think about traffic information, which is something which might not be worth getting your phone out to check every day, but if you're on your way out of the office, if you can quickly check your watch and see it, it's a small convenience you might not otherwise have. And the last thing is small apps on these devices where you can do a little bit of stuff without having to get your phone out. Of course, this is limited in scope by how long you can use a screen the size of an Android Wear device and how long you can keep your wrist up to use a device. So with those in mind, we can think about why you might want to build a wearable app or when you might not want to. So we should consider first, when is the defaults for all of this stuff good enough? So the integration that you get for free with notifications especially, where the phone will send them on to the Wear device without any additional effort on the part of the developer. Sometimes that's good enough, but sometimes it is worth making a wearable app to go along with a phone app. And we came up with a short list of the properties we think a lot of good wearable apps have. They tend to save the user time, especially compared to having to get your phone out or having to go and find something. If you can have something presented to you directly whenever it's relevant, good wearable apps tend to present very small bits of information at a time. So again, going back to the traffic example, you can see roughly how long it might take you to get home on your usual route as compared to, say, detailed traffic information, which just, given screen size limitations, that's not very useful in most cases on a wearable device. And the last thing about these is that to make full use of them, you only have to look at them for a little while. This goes back to, I think, what people call gorilla arms, where just holding up your wrist to look at your watch for a long period of time will tire you out unless you're basically a gorilla.
All right, so eventually after kind of going through all these considerations, we reached the point where we needed to sit down and come up with an actual app that we wanted to make for our demo, our learning experience. So we started with pretty much a laundry list or a wish list of requirements, things that we wanted to do. So we wanted something that was going to be simple to implement. Whatever we made, we didn't want it to be a massively involved project, at least not to start out with. If you've ever worked on a personal programming project, which I'm sure a lot of you have, then you probably know, or you've probably experienced that it helps to just get something done, get something out there, and then you can iterate on that product. And then we wanted a real-world use case, since the whole point of this was what makes a useful Wear app. We wanted something that could at least mimic a real-world use case, something that we could see ourselves or others actually using. We wanted it to be useful cross-platform. Part of the fun of wearables, to us at least, is that there are systems available to both of the major smartphone ecosystems. Sorry, Windows. So we wanted something that could be enjoyed across both of those, to be able to interact together. And then finally, we wanted something that we could expand or iterate on. So even though we wanted to start with something simple, you know, it would be cool to keep going on it. So what we came up with is a little project that we call YesNoMaybe. It's pretty much a little thing. It's kind of like text messaging in that you send people simple questions, except they only get the option to respond with yes, no, or maybe. So it's very usable through solely interacting with notifications. It's fulfilling most of our criteria for usefulness. It seems like something that you might use if you just want a quick answer to something. Maybe you have like a friend who always wants to give a really drawn-out answer to something. You just want a yes or a no or a maybe. And finally, it makes for a pretty cool demo of wearable tech in that it seems pretty handy to be able to just quickly respond to something on your wrist. And the fact that we do have that limited list, just the 3 options, makes it a pretty good candidate for that.
So when we were starting on YesNoMaybe, we had to think about how we wanted, what parts of the app we wanted to make available on the wearable devices and what would be just limited to the phone. So the breakdown we came up with was the phone, of course, you can see all of your messages, you can reply to incoming ones, and you can send new ones. But on the watch, at least initially, all you'd be able to do is see the latest message that you've got and respond to it very quickly. So this is, we felt like just seeing the message and responding to it really gets at what we were thinking about with wearable devices, where you get into something, do what you wanted to do, and then you can just move on. And as we were thinking about this, we very quickly ran into the backend problem, where, of course, to be able to send messages between people, we need some kind of backend. And being mostly mobile developers, we didn't want to have to do that as well. So with the 3 requirements we had for any kind of backend, being able to have users and a little bit of user management, being able to do push notifications, and being able to get back your message history. If you log in on a new device, we were looking for something to handle all of these. And I think we came up with a particular service that I think both of us really liked once we got started with it.
So Parse, if you haven't heard of themselves, they describe themselves as a way to instantly add a powerful core, push notifications, and analytics to your app. So basically, they let you build out a model and some simple logic around it, and provide a pretty decent user and account system. And they also provide native SDKs for both Android and iOS. We had both used it a little bit in the past, but neither of us had actually built an app from the ground up with it, so we thought it would be another cool little piece for the learning experience. And perhaps most importantly, Parse is completely free for the light usage that we had in mind, so that was good. That never hurts. Do you want me to take this one?
Yeah, go ahead.
Okay, so just a little bit about Parse, just because it is kind of interesting. Parse Cloud is kind of the piece that lives in the back end. It's Parse's name for the management system that lives back there. So it lets you create custom logic surrounding your app in order to accomplish whatever your app needs. So in YesNoMaybe's case, this is our push notifications that we need to be able to have the logic to when to send those out and what they look like when they get sent out. and then handling the responses and everything like that. The functionality is offered as part of the core Parse feature set. It's still free. The only potential downside to this is kind of the difficulty of using Parse Cloud. Any cloud code that you do has to be written in JavaScript, which one, neither of us were very skilled in, and two, isn't the best documented thing. You kind of have to dig around. But as long as you're not envisioning anything too complex, which we weren't, it's probably a decent thing to consider for something small like this. I don't know if you want to handle this one.
With Parse, early on, we found out about some of the hooks that they have available, and I think this one worked out really well for us. So we have our basic question model for messages that you send, and Parse has this after save method where you can set up a method that'll run every time a user updates one of your updates this question model class and sends it to Parse. So with this, we can this particular method doesn't do the consistency check. That's another method before save that they have. But this one, when you save a question, our code will look at the question, pick out who you've addressed it to, and then send them a push notification. And here you can see maybe some of the reason we might have run into trouble with it. We have to do this get recipient and then a fetch method and then give it a callback to run when that's finished. And this was a major pain point for us since, as far as I can tell, this certainly wasn't anywhere obvious in the Parse documentation that I saw. I think another developer who was helping us for a little bit stumbled upon this and helped us out a little bit.
Shout outs to Google search.
Yeah. So this code handles our automatic push notifications. But Parse also does user accounts for us. So the Parse SDK that's available for both platforms actually has a user class. On Android, it's named Parse User, and Parse is able to do registration, login, a little bit of authentication, and we can give it any additional fields that we want associated with users, and we can, using our cloud code, we can make sure that any client apps that we made do include all of the fields that we want.
So we'll kind of move over this pretty quickly. We just kind of wanted to give an idea of like how handy Parse was for something like this in quick sense. So this is just a really quick look at the registration method. You can see at the top there, we're just creating a new user object which extends Parse user. We're grabbing information from our edit texts, which you can see a screenshot from the Android app over on the side of the screen. We're just passing that in. We're calling that sign up and background call, which Parse provides. It provides its own callback. You handle it all right there. It was really convenient. So that's probably enough about Parse since you came here to learn about Wear stuff. The only takeaway from that would be tools like Parse can be pretty handy if you're creating relatively simple apps that need some backend service functionality, but you either don't feel comfortable doing that or you don't feel like you have the time. So for the rest of the presentation, we're going to take a deeper dive into the actual Wear stuff, wearable stuff, both on Android Wear and WatchKit. We're going to talk some about what specific functionality we decided to leverage on each platform, and then show some of the code. However, before going into that deeper detail, we thought it could be handy to just show like some screenshots of the app so you get a better context for what exactly it looks like, what it does. It's really simple. As you can see, it's pretty much only 3 screens. There's the login register screen, which you saw on the last slide. There's a message list, which you get on the phone, and then there's sending a message. So we're going to jump into Android first. I'll go right into that. So all of the communication that we do with the Wear device is done via notifications, in YesNoMaybe at least. There are, however, 2 fairly distinct ways within Android Wear which we could have gone down. The first and the simplest is just pretty much using the default notifications. Android provides a notification builder class, which lets you specify a title, a message, an icon, and a set of actions. This is how you're going to do notifications at any point, whether you're using a Wear or just a phone. And if you use this, and a user has a connected Wear device, then they're automatically going to get those notifications, unless you specify that they shouldn't. It is, however, possible to create an entirely custom notification. These custom notifications can only be displayed if they are launched from the Wear device. So you actually need to create a Wear app that runs right on the wearable device. It can't be triggered directly from the phone. You can set up a messaging service from the phone, which basically sends a message to the Wear device and says, display this notification. So you get the same idea, but you still have to go through that extra step of creating the Wear app. This is the part where I tell you that unfortunately we didn't actually have time to go through that second, more complex, more interesting process completely. We did get most of the way through it, so we are going to go into it. Hopefully you'll still get something from it, but I don't have a final working product to show you of that. But we will go into some detail on both. So the first technique, the simple notifications, you're entirely relying on the notification builder, like I mentioned, to create and display. So you get the title, you get the body text, you get the icon. It is also possible to specify a few different styles that Android provides. There's like a big text one. There's a media one if you need to leverage that. So you do get some larger degree of customization, but it's not completely custom. There are still some details for our particular case, though. So you still need to decide when you actually want to trigger it. In our case, since what we're effectively doing is displaying notifications for push, we need to detect those pushes, grab the information from those, and then display that notification up to the user. And then we also want to make sure that we can respond to those notifications. Since we want the user to be able to specify yes, no, or maybe right from the notification, either on the phone or on the Wear device, they need to be able to actually do that from there, so you need a service set up to get those responses. So we'll take a look at some code now. Actually, we're going to take a look at a couple screenshots from the Wear device, I guess, really quick. So this is kind of what it looks like with the default notifications. You get notified that there's a new question, and then you can swipe over, and there's a separate screen for each action. So there's a yes screen, a no screen, and a maybe screen, which you just get automatically for specifying the actions on the notification. It's obviously not the most fancy, but it's certainly workable. Okay, here's our code. So this is the first relevant bit of code for the push receiver. Since we're using parse, we're extending from that parse push broadcast receiver. However, the logic is going to be really similar if you're just using traditional GCM or anything else like that. You'll just want to extend the normal intent service. Google does provide a pretty good guide for getting up and going with this. If you haven't seen it, I won't go too much into it. So all we're really doing here at a high level with this code is creating a notification and displaying it. So if a push comes in, we check to see if it's a new question. There's that action new question in the switch. If it is, then we call our method to create our specific notification, which is here. So here's the notification builder for just this default method. You can see here we're using the notification compat builder. This just means it'll work backwards. It's the same as any of Android's other compatibility libraries, effectively. It's a builder. You just tack on whatever you want. It's really similar to an alert dialog builder if you've ever used that. The other important thing that we see here is we have these pending intents. You can see we're defining and then passing it along with the actions, which represent the different buttons or screens that you'll get on the different notifications. So essentially, a pending intent is something that you set up to run at a later time, and it allows another service or app to run with the same permissions and context as the app that you create the pending intent from. So in this case, it lets the launcher or the notification service come in and send off the right intent with the right permissions to notify our app that this has happened. You can see here the pending intents themselves are pretty simple. You effectively create a normal intent, with whatever information you want on it. Right here, we're just setting some IDs and the response. And then you just wrap it in a pending intent. So here's our response receiver. This is where we're going to come into after a user has selected a response. So let's say Brendon asks me if I want to build a snowman. The answer is obviously yes, so I select the yes action on the notification. And this will trigger the launching of the pending intent, which will in turn come into this receiver. From there, it's really simple. You just grab all the information off of the intent the same way you might from an activity. If you were passing information in between those, there's just that get string extra. You can pass things besides strings. We have a little bit of logic to make sure that we actually came into it correctly, and then from there, we're just making a call to parse with the information. It's really pretty straightforward. The only other thing to point out is that the way that it detects is, if you remember on the last slide, we are setting that action respond at the top, and then we have that action response defined here. And then you just declare it in your manifest the same way you would with any other service. And then the last thing we have in the response receiver is this callback, which is a function of parse. But essentially, we're just making sure that we're just missing the notification after it's been successful. Just as when you're displaying the notifications, all you need to do is call that cancel method on the notification manager, and that'll handle getting rid of the notification on both the phone and the Wear device. So that kind of covers the simple part. Before launching into the custom notification section and covering what I can, I do want to give another shout out to Google's SDK samples for Wear. Two in particular are going to be super handy to look at if you are interested in further pursuing this. There's the synchronized notifications and wearable notifications. Synchronized notifications is going to kind of give you an idea of how to set up the data layer that allows you to communicate in between the Wear device and the phone. And the wearable notifications gives kind of just a nice general overview of setting up notifications for the Wear. And also lets you see some of the layout stuff that you can do with like wearable lists. If you don't know how to access these samples, it's really easy if you use Android Studio. You can just go File, Import Sample. It'll give you a dialog with all the things to choose from. You can scroll down to Wear and choose the one you want. If you already knew that, I'm sorry. I actually only found out about it like last week, so I thought it was super cool. It's like, look at the samples. That sounds really hard, but it's not. So custom notifications. There's a few components necessary to creating one. The first thing that I mentioned earlier is that you're going to need an actual Wear app to go along with your phone app. So within this Wear app, you're going to create an activity, which you're going to actually display for your notification. So your entire custom layout that you're defining for this custom notification, you're just going to create it the same way you would any other activity or fragment or view that you would display within a normal app, just keeping in mind the design constraints of the wearable screen, obviously. The other thing that you'll need within your Wear app is a wearable listener service, which is just something that you extend from. There's some methods on there which you can override, and it pretty much just offers you the functionality you need to get messages through that data layer API, which we'll go into. And then on the phone app side, you need to set up your Google API client, which will allow you to send those messages to be picked up by the wearable listener service. And then the other piece, which is kind of optional, I guess, is just the standard notification service, like we saw in the last section. If you want the notifications to show up on your phone as well, you're still going to need to do that, because your custom Wear notification obviously won't work on the phone. So a custom notification, I've gone over that, needs to be triggered from the Wear app. It's controlled by an activity. And we're using pending intents again, just in kind of a different way to tell the notification to display our activity for the view. So here's a slide that's just completely full of code to demonstrate the way that you're going to put together your notification. You can see that we're still actually using the notification builder, But the main difference here is that we're using this wearable extender you can see maybe halfway through the first method. So the wearable extender just pretty much defines wearable-specific components of the notification. So in this case, we're calling that setDisplayIntent and passing in a pending intent to show our activity. But you can also do other wearable unique things with this wearable extender. For instance, you can call addAction on the wearable extender instead of on the main builder, and it will show those actions only on the watch instead of on the phone. So if you could only respond to maybe, for instance, on a watch, if for some reason you wanted to do that, then you would just call addAction on that wearable extender instead of on the main builder. So setDisplayIntent is what we're calling. Again, creating the actual pending intent is really simple. It's that second method down at the bottom. We create a new intent pointing at the activity that we want to display, set any other extras or information we want on it, and then wrap it in a pending intent and set that as our display intent. So kind of an aside a bit on actually designing the notifications. If you saw, there was a presentation offered earlier in the day that was kind of more in detail on Wear design. That was really good if you are interested in that. But basically, Google offers what they deem an unofficial support library called the Wearable UI library. It's included along with the rest of the support libraries in the Google repository that you can install through the SDK manager. And you'll need to include it as a separate dependency, just like ResponseReceiver, if you've ever used that. So pretty much what the Wearable UI library offers is a set of patterns that Google deems as being pretty good use cases for Wear design. Some of the ones that I found really interesting are the card fragment, which pretty much lets you really easily create a card view with the information that you want. That's that first screenshot up at the top of the slide. It's like another builder type method. You just call like cardFragment.create, and then you can set a title and a message and an icon. And then there's the wearable list view, which gives you basically just a wearable optimized list, like you can see in the middle. Obviously, it's impractical to have a list of like 10 options or whatever on the side. So this kind of allows for a small view. You can do stuff like scale up the center icon, makes it really convenient to use on a watch screen. And then finally, there's the grid view pager, or 2D picker, as Google usually refers to it. And if you've used a Wear device, then you'll notice that a lot of the different pieces allow you can swipe up and down, you can swipe side to side through different things. So this is just an adapter that you can set up. You can use fragments or views or whatever you want, but it allows you to create a two-dimensional array so that you can control both the up and down and the side to side. It's really straightforward. Definitely the Wearable UI library is a really cool set of tools if you are looking to create either these custom notifications or a full Wear app. I'm not going to go into much more detail on them. Suffice to say they exist. There's really good documentation surrounding them, and there's also really good examples in the SDK samples. So now I just want to take a bit of a look at the data layer. Here's the phone side. All of the communication that you're doing is going to be through the Google API client. So you can see that method at the top is just creating the API client. We declare that we're using it with the Wearable API, which is declared as part of the Wearable library. We add some callbacks. Those are just interfaces that you can add to wherever. You could also use anonymous inner classes if you really wanted. Just lets us know, when we get the connection, et cetera, et cetera. And then finally, the method at the bottom is actually sending the message. Again, you can see that it's fairly straightforward. You create what's called a put data map request. You specify a path or an action on it. You add any extras you want to it. Here, we're just pretty much sticking straight the JSON we get from Parse as a string to an extra on the data request. And then finally, you call wearable.dataAPI.putDataItem. You specify your client, which you need to make sure you connect on, and you just send it through. And then hopefully, that will be picked up here in our wearable listener service. There's actually, like I mentioned, a few different methods that you can override on wearable listener service. Probably the easiest one to use for something like this, though, is the onDataChanged one. This is what Google uses in their SDK sample. So all you do is you get a buffer of all the different events that come through. So we're checking to see if our data event is newly added. That's that type changed tag. And then we pull out our information, and we do whatever we need. I got up to this point. I did not get up to the point of actually being able to display it on the watch, so I won't show you that part, but it does work perfectly in the SDK sample, so I again encourage you to take a look at that. All right, moving on to WatchKit.
While we were looking at doing notifications with Android Wear as well as WatchKit, we noticed that they actually work very similarly in some of the ways of how you manage when a notification gets displayed on the phone and when it gets, and how to handle default notifications and custom notifications on the watch. By default, just like with Android Wear, the phone will decide to send on a notification or just show it on the phone itself. But you can do custom notification. You can customize the way a notification is displayed. But that again requires you create a watch app to be bundled with your phone app. And here I've got some screenshots of the custom interface that I did make in the watch app for YesNoMaybe. And WatchKit, which is the SDK for working with the Apple Watch, supports two different kinds of custom notification interfaces. This static interface, the one on the left, and the dynamic one, which has a little bit more stuff on the right there. With the dynamic interface, when a notification comes in and it goes to the watch, your watch app gets a chance to run some code, update the UI as it sees fit, and then report back to the system saying that it's done. So you can have a pretty good amount of flexibility in what you want to show for these dynamic notifications. But in some situations, WatchKit will display the static interface instead. I think the most common one is just when the watch is low on power and the OS decides it doesn't want to run third-party code if it doesn't have to. So it'll show your basic interface. It looks for a particular key in the notification payload and displays that directly. So one of the things we had to do in our Parse Cloud code was make sure the text on that string does include all of the information that you need to be able to decide what your answer for a question will be. If you saw at the bottom there are these actions on both of these interfaces, and on iOS, these are called notification actions. These are pretty new. Apple introduced them for iOS just last year with iOS 8. And these are just quick actions that users can take on notifications. So unlike with previous versions of iOS, if you get a notification on a recent version of the OS, and the app does support these quick actions, you can take an action directly on there, and when you do, the OS will launch the phone application, run your logic to handle the action, and in that logic, you can do things like network requests or any other background tasks that you might need to do. I've got a snippet of the code I have to set up these actions, and the breakdown of this is just creating an action, creating a category, and saying, when a notification of this type comes in, I want you to show these actions, and then registering for notifications the same way that one normally does for actionless notifications. And to handle these actions, there is a particular method on the app delegate in the phone app that gets called. Here I'm looking at the identifier, which will be a unique key that I gave the action on the notification. So that's how I can tell what the user did in response to my notification. And then I try to create my model object. If it succeeds, I know it's the action that the user took is the one that I'm expecting to handle here. So I can pull the parameters that I need to it, and then send on the information from that to Parse. And of course, you have to make sure to call the completion handler in this method, or iOS will not treat your app well. If you don't call that enough times, the OS will start really cutting down on the time that your app has available to run your custom code, and at an extreme, it'll just stop showing your actions because it won't give you any chance to run your custom logic. So you have to make sure to call those completion handlers in here. And as for the actions themselves, this is what it looks like on the phone here. One of their limitations is the phone can only show up to 2 actions. I think this is more of a problem with the smaller screen sizes, but even on the 6, things get pretty crowded with just 2 actions. But on the watch, you can show up to 4 actions in a vertically scrolling list before, and then below that is more of the standard system UI. As for developing a WatchKit app, as opposed to just the notification part of the interface, there are a few particular points from when we were developing YesNoMaybe that I want to cover. The first is that you have to make your entire UI in the storyboard, and you can't add any custom view elements in code. So that means what you have in the storyboard is all that you'll have available. The best you can do for conditionally displaying things is adding a bunch of views into your storyboard and then hiding them at runtime. So you don't get a lot of flexibility, but on the other hand, applications on the watch, according to Apple at least, since it's not out yet, they're going to be very efficient. And if you notice here, there are 3 big arrows pointing from the left side of the screen to the right side of the screen. Those are all the entry points from our application. At the top there is the main entry point, which is what you'll get if you tap on the icon for YesNoMaybe on the watch interface. That's just, I suppose, what you would refer to as the watch app itself. At the bottom there, you can see both of my notification interfaces. And on that arrow, you might not be able to read it, but it says question, and that's the identifier, that is the category that we're using for notifications in YesNoMaybe. And with the categories, you can define multiple sets of actions on notifications, and that's how the OS knows which actions to show and which interface to make when a notification comes into the watch. So you could have very different interfaces for different types of notifications that come in. And the last one is the glance, which I'll get to a little bit later. We actually, after building one out, actually decided that that might not be suitable for YesNoMaybe. But going back to the main watch app interface, you can see there's not a whole lot of space to display stuff, as you might expect. So we just display relevant information from the question, and then we have our response buttons. One of the interesting things about developing the watch app is that there are really 2 kinds of interfaces that you can make. This page-based one, you can see there are some dots at the bottom. Each dot is a page, and you can swipe left and right between them. And one of the quirks of WatchKit is that the number of pages you can have, like everything else that's UI, has to be fixed at compile time. So both of these pages you can see I have in the storyboard already, and I can't make any more without adding them in here. So it is a little restrictive, but it's certainly enough flexibility for what we wanted to do. The other kind of interface you can make is more or less a table or a list view, where you have a bunch of items in a vertically scrolling list, and you can select one of them to go into detail. But I think that that kind of list view isn't particularly well suited to apps on the watch, because that's getting away from the kind of very fast interaction that we want to go for with our apps. As for actually working with a WatchKit app, in keeping with the light resource usage on the watch that you get for UI elements, Apple encourages you to do as much work as possible in the main phone app instead of on the watch. So we have this method to open parent application you can call from any interface controller on the watch to have the OS open up the application on the phone where you can run whatever task you need to do. You can kick off a background task, do something asynchronous that might take a long time, and then maybe get back a response from the phone. And as for passing data from the phone to the watch, after a bit of trial and error involving databases and other very heavy things, I came across this third-party library, Wormhole, that uses a clever combination of the file system and low-level notifications to keep to pass messages asynchronously, such that the watch app can get them if it's running, or if it's not running, when it does launch, it can look for one of these. Here I've got some of the code that we had to run logic on behalf of the watch. So when the system calls into this method, we look at that user info object, and we see what the watch sent us. Again, if we're able to create an instance of our model, we know this is one of the requests that we know how to handle, so we can go ahead and do it what we want to do. Here, again, we're using parse to say, this is the response that the user had for this question. And I want to say again that Parse Cloud saved us a bit of work here, where instead of having to store all of our questions on the phone, do a database lookup or anything like that, we're just able to take the ID, which the watch already has, and the user's response, and send it off to Parse. And Parse Cloud code takes care of finding the question itself and setting the response. So that simplified the code that we had to write here, I think, a good amount. And for sending information from the phone to the watch, you can see it tends to be pretty simple. This code looks at the list of questions on the watch, picks out the sender names from them and the number of questions that there are, and then uses that Wormhole library to send them along to the watch. And that's it. I actually don't have any more code than this for working with that library. Just somewhere one of these wormholes is created, and I can use it as much as I need to. And on the watch, like I said, this Wormhole library supports sort of asynchronous communication. So when my watch interface activates, it gets a wormhole, it goes and looks to see if there's a message there and displays it. If it is, if not, it just keeps on going, and it subscribes to these messages. So with this wormhole library, whenever the phone sends a message, the watch will pick it up immediately and update its UI. So there's no additional synchronization logic that I need. I don't need to worry about whether the watch is running or not when the phone updates, and my UI updates immediately as soon as the phone knows about new objects. So that worked out really well. And the last thing, which I mentioned on that storyboard, WatchKit also supports this thing called glances. Glances are supposed to be a very, very fast window into some information that your app might want to display. There's no way to do user input on one of these, so you don't get to put buttons on it or anything. Just if a user taps on your glance, they go into your main app. And after building it out, we realized we forgot to ask, is this actually useful for us? And for YesNoMaybe, I don't think so. There's the main app itself is already small and fast enough as it is, and having a glance really doesn't get you much. So in the end, we decided to take it out. But building it out is pretty simple. It's more or less the same as building out the notification interface or the main watch app interface, and could be useful. If we go way back to the traffic example, a mapping app or routing app, if it gave real-time traffic whenever you switch to the glance. That's the kind of thing that would be more useful. But for YesNoMaybe, it fell into just looking at the data that's already there waiting for you, and it just wasn't that useful. So we're planning on demoing the app, and we'll get to that, but we're going to need, yeah, well, first we can take any questions. Go ahead. There's currently no access to those sensors on the watch, unfortunately. So fitness apps are kind of limited. You can use some of the health kit data to display stuff, but you can't get it, can't find out that stuff yourself.
Yeah, so the question was, how much access do you have to the sensors on the watch? On WatchKit, you don't really have that. Android Wear actually gives you a fair amount of access to whatever you might want. Generally, you're going to be accessing it through the phone sensors, but you do have that access available to you if you want it. Other questions? All right.
I think we have time.
Yeah, we can do a quick demo. Do you want to plug yours in really quick?
Yeah, we're going to need to switch computers. So we do have communication between both versions of the app working, but let's see. The iOS app is currently all set up with the beta version of Xcode, and it's pretty difficult to get it running on a device at the moment, so it's running in the simulator. But I'm going to send Kenton a question and see what he says.
Right. 4 different user accounts.
I think I'm just going to ask him, you like me?
So I see that on my watch now. I know you can't see that. I'm sorry for that. So I'm just going to respond with maybe. Not really sure.
And the iOS simulator doesn't do notifications, but if I refresh, I see Kenton said maybe. So there's still hope for me. And I think that's it.
Yeah, that's pretty much it.